Hi, welcome to a short video to help you with pie charts in the QTS Numeracy Skills Test. We're going to try and cover a few different varieties of question that come up in the QTS test. I'm just going to start off by telling you what hasn't been coming up in the test so far. So if you think back to when you're in school, you probably have either good or bad memories of doing pie charts in school and getting your protractor out and measuring angles and working out what angle you would need for a certain portion of the pie. You don't need any of that in QTS. QTS is all about looking at a pie chart and interpreting the data. No different than looking at a bar chart and interpreting the data. And that's what they expect of you as prospective teachers, is not to necessarily draw pie charts yourself, but to be able to recognize and glean information from a pie chart in different circumstances, and particularly to do with numbers of pupils and levels achieved, which is what this question is all about. Okay, so let's get started on this question. There's two main varieties of question, and I'm going to cover those first. Okay, so this first question, okay, the most important bit first of all is to recognize what the question is asking you for. And in this case it is asking you for, it says how many more pupils. Okay, so if you maybe look at the question and give an answer that's got the word percentage in it, that can't be a correct answer. The question is asking for how many more pupils achieve level 5 in 2012 and 2011. Okay, so we need to work out how many pupils achieved level 5 in each of those 2 years and then subtract them. Okay, so when we look at the pie chart themselves, the pie charts don't have numbers of pupils on them, they've got percentages. Okay, so in 2011 we've got 15% of 80 pupils achieved level 5. Okay, so this is the 2011 figure, and the 2012 figure, it's 20% of 95 pupils. So where did I get those numbers from? Well, first of all, level 5, you need to make sure that you're looking at the right colour. Really bad mistakes if you're picking the wrong colour. That's something that you really need to eradicate pretty quickly. It's easily done, but you've got to be quite precise with these. Okay, and where did I get the 18 and 95 from? Well, there's these two numbers up here. Very important. You'll see in the next question that those two numbers are not important at all. Okay, so now let's move on to kind of how we're going to do this with a calculator. Second section of the test, you're allowed a calculator. By far and away the best way to do this is to use what are called decimal multipliers. Okay, so 15% for your mental arithmetic section, you do need to know that 15% can be written as 0.15 as a decimal. So we're going to use that and stick that in your calculator. You should get 12. Okay, same with 2012. Okay, I'm going to write 0.2. Many of you, I know, would write 0.20. It's not incorrect, but it's not really strictly correct either. It's very important that you realise that this 0 here is unnecessary, because people do get themselves confused. Okay, it is very important that you understand 0.2 is the equivalent of 20%. Okay, but if you did type the 0 in on your calculator, it wouldn't be wrong. Okay, now you should get 19 this time. Okay, and you can see that the difference is 7 pupils. So there were 7 more pupils that scored a level 5 in 2012 than 2011. So that would be our final answer, 7. Okay. Okay, so we move on to the second question in the pie chart video. You might recognize these two pie charts. They're exactly the same pie charts that we just looked at. Okay, and I've seen from experience, either with one-to-one tuition webinars or the Facebook page that I run, when people get these questions wrong and they look at this question and say, what am I doing wrong? Yeah. Okay, and they're very common. Okay, and the first thing that I did in the previous question was to circle what they were looking for. They were looking for the number of pupils. So what are we looking for here? The percentage point improvement. Okay, so Very, very different from the previous question. It's got nothing to do with the numbers of pupils, okay? And what that means is that you can instantly cross out these two numbers at the top. They are not needed. And a lot of students, when they see this question, because the numbers are at the top of the pie charts here, they presume they must have to use them. No, you only use them if the question is related to those numbers. The question's got nothing to do with those numbers here. Okay, so that's the major difference between these two questions. Now, once you've done that, this question is super easy. Okay, let's have a look at it. Okay, we're looking for level 4 and 5, so green and orange. So I'm going to just cross out the other two colours. Okay, I know you can't do that on the screen in your test, but your eyes need to go to the correct colours. Okay, and you purely just look at 2011 and you add these two numbers up. Okay, so let's write that out over here. In 2011 we had 15% of the pupils achieve a level 5, okay, and we've got 37% achieved a level 4, and we add those together and we get 52%. Okay, and now we do exactly the same, just for a different year, different pie chart. We're going to do 20 plus 46. Okay, pretty easy numbers, but you know, use your calculator if you need to in this. Okay, sorry, just trying to find the erase button there. Okay, let me write that a little bit bigger. Okay, but yeah, take advantage of your calculator. It just helps, it takes the pressure off you and it helps you avoid silly mistakes, really. Okay, I mean, these numbers aren't difficult, but look, most people that are struggling with this test, you know, you just don't like numbers, you guys, so that's fine. Get your calculator out and use it. So the difference between these, 66 take away 52, it's clearly a 14% difference. And of course that is an improvement, because 2011 was the lower figure, 2012 was the higher figure, so this is a 14% improvement. Okay, we didn't need to know how many pupils there were. Really, the pupil numbers at the top in this particular question are just a red herring. Okay, very important, because you know, in real life, and in, you know, let's put this in the context of a teacher. If you get given a pie chart like this at school, you're going to be expected to interpret the information that you need, or maybe what you've been asked for, not some other piece of information. But that doesn't mean that the other information won't be on there. Okay, very similar to bar chart questions. You've got to pick out the right data. You're not always going to look at every single bar on a bar chart. You're only going to look at the ones that you're being asked about. Okay, and obviously I'll be doing a separate video for bar charts. Okay, so it's about looking at numbers and not worrying about them if they're not relevant to the question. Okay, so moving on to another quick pie chart question. One of the dreaded kind of indicate all the true statements questions. Okay, some of these can be quite tricky. Not normally with pie charts though. Some of the other questions, either to do with scatter diagrams and bar charts, those kind of things, they can be quite tricky. I'm going to hopefully show you here that this is a relatively straightforward question, but I want to illustrate the really key points and the common mistakes that people make with these questions. Okay, so we look at this pie chart and we haven't got percentages on this time. Okay, we've got numbers of pupils, and again, that's very important. You need to look at a number and know what it means. So this 36, it could be 36%, but it would have to explain that to us somewhere, and it doesn't. It says a group of sixth form students state the subjects that they plan to study at university. The information is shown on the chart. 36, not 36%. Okay, so when you look at the three statements, they're all forms of a proportion. Okay, 3/7 is a proportion, 1 in 12 is a proportion, 2/7 is a proportion, a percentage is a proportion. You can write a proportion as a decimal as well, and the fractions, decimals, percentages, they come up everywhere in your QTS. Okay, I quite often get students say, "Oh, Peter, can you do a video about proportion?" I don't need to do a separate video about proportion. You just need to understand that the word proportion really just means fraction, decimal, or percentage. Okay, well they're the main ones. The other extra one is probably really this one where it says 1 in 12. But I'm going to show you in a second that that is a fraction really. Okay, now doing these questions, there is a very important piece of information that you need that is not given to you, and you need to work it out straight away, and it is the total number of students. Okay, so I hope it's fairly obvious, but you would just take each of the numbers on the pie chart, okay, and add them up on your calculator. And you can't do any of these proportion questions without that number first. Okay, so I believe that adds up to 84. Okay, you can check that on you can pause the video and check that on your calculator if you like. Okay, now what that means is that every single question that we get asked on this, we're just going to keep writing over 84, over 84. Okay, and we're going to put some other number at the top depending on what the question is asking us. And it doesn't matter whether the statement is given a fraction in the answer, a 1 in 12 in statement B, okay, or a percentage, or a decimal. It doesn't matter. You have to start with fractions in this, and this is very very important thing for the mental arithmetic section in this. You tend to start with fractions and then you maybe convert them into a decimal or a percentage. Okay, so in this question, once we've got this kind of idea that we need to add them up, and we just write fractions like this. Okay, let's just clear these little question marks. Okay, so if we look at this is going to be statement A, statement B, and statement C. So when we read statement A, I would encourage you to ignore the 3/7. Okay, there's more than one way to do this, but I'm going to just stick with one way of doing it that I think is the best. Okay, and you just look at the category. The category in statement A is natural science. So natural sciences is the purple, so it's the 36. So you put the 36 at the top. And I'm actually going to do nothing with that for a second. Okay, we're just going to go and do B and C in exactly the same way. So statement B is talking about social sciences. Social sciences is the green, so that's going to be the 7. So we put this at the top. And statement C is art, which is the orange one, which is the 13. Again, try not to pick the wrong color. Okay, now in terms of converting each of these, okay, there's a few different things that you can convert them to. As I said, it could be a simplified fraction, or as I said earlier, you could convert it into a percentage, a decimal. They're the main ones. Okay, now you need to be able to simplify fractions and know your times tables and do all sorts of complicated stuff in the mental arithmetic section, and you need to be able to do it quickly. But this isn't the mental arithmetic section. Okay, so again, I'm going to get you to be using your calculators, okay, to help you here. As I say, again, this isn't the only way to do it, but I'm trying to give you a quick, precise, foolproof way of doing it that will avoid mistakes. Okay, so what we do is we're actually going to turn this into a decimal. And now that might seem an odd thing to do when the answer in the statement is not a decimal, but just bear with me. I'm just going to bring up my on-screen calculator. Okay, you'll see why we do this in just a second. Okay, so we do 36 divided by 84 on our calculator, and we get this not very nice looking decimal, 0.4285. I would encourage you to maybe write down about 4 decimal places, should always be enough. Okay, now all we're going to do now is we're going to go back to statement A, and their suggested answer is 3/7. So I haven't used the 3/7. I'm just taking their suggested answer and I'm going to turn that into a decimal. Now, just to save a little bit of time, you'll have to trust me here. It's the same. And actually, no, I'm going to do it. Look, it won't take long. Let's clear it. 3 divided by 7. Okay, you can see it's clearly the same decimal. It means it's the same fraction, and therefore statement A is true. Okay, so if we move on to statement B, okay, I'm just going to clear some of this so we've got a little bit of room. Okay, so looking at statement B, we can do the same. Okay, 7 divided by 84, and we bring that up as a decimal. Just put a few 3s in there, we don't need all of them. It's actually a recurring decimal. Okay, now statement B is a slightly odd way of writing stuff when it says 1 in 12. Okay, 1 in 12, okay, is exactly the same as this. Okay, and the best way to kind of look at that and think about it is if you were doing a test and you did 12 questions and you got one of them right, another way of saying that is that you got 1 in 12 right. Okay, but normally we write test results as a fraction. So if somebody got one question right and they did 12 questions in total, you'd write the fraction 1 over 12. Okay, so really, although statement B is written in a slightly different way, we're really being asked, is this the same as 1 over 12? And again, we can just go to our calculator and do 1 divided by 12. Okay, and you should see that this is going to be the same. Okay, there you go, it's the same. I'm not going to write that down over there, I'm just going to write true. Okay, now if we do exactly the same for statement C, we've got 2/7. Okay, so we do 2 divided by 7. So really what we're doing is we're just turning everything into a decimal and then comparing them. Okay, as I say, it's not the only way to do it. Okay, but I think it's a way that gets you guys using your calculators and it takes the pressure off you. Okay, I think that was a 7 on the end there, not too important. Okay, and oh, sorry, I've kind of slightly done that round the other way. It doesn't really matter. You've got to do these two calculations and compare them. Okay, so it doesn't matter what order you do it in. Okay, so we try 13 divided by 84, and this time you're going to see a slightly different result. Okay, now really you don't need to waste time writing that down. You can clearly see it is different from 2/7, so it's a false statement. Okay, we don't need to get sort of too involved with exactly what the numbers are or what the difference between them is. If it's not the same, it's different, it means the statement is false. Okay, so I hope that gives you a good way of kind of dealing with these proportions. Okay, I know the word proportion isn't written in the question anywhere, but any fraction or decimal or percentage or a 1 in 12, they're just examples of proportion. Okay. Okay, so one more question on pie charts. The style of this question is exactly the same as the last one, so I'm going to go through it relatively quickly. Okay, so do you remember what we said? The most important number is the total. In this instance, you know, it could be total of pupils or students or something. Most of your QTS questions are related to teaching in some way. This particular one is members of a class, but it doesn't really matter. Okay, so we add our four numbers up. We've got an 11, a 3, a 4 and a 12. Now I'm going to do that without a calculator. I think that is 30. Okay, but in the test make sure you use your calculators to avoid mistakes. So as we mentioned earlier, we're really going to be thinking of this as 3 fractions for each statement A, B and C, and we've just got to correctly pick the right colour for each statement. So the first statement is talking about a level 4, which is light blue. Okay, so that one's a 12. Statement B is a level 5, which is the dark blue or purple, so that's a 4. And statement C is a level 3 or lower. So this question, there's a slight difference here. Level 3 or lower, we're going to add the green and the orange together. Okay, so that will give us 14. So you can see there that there's a slight difference to the last question, and it's just to do with the wording. You have to really keep an eye on the wording with all of these questions. Okay, you know, when this video is a pie chart video, but if I'm doing a video on pie charts or bar charts, or line graphs probably as well, they're all really very, very simple types of graph. That's not the thing that trips students up. It tends to be the wording in the questions. Either people just getting used to the wording, or just really, if I'm honest with you, just not reading it correctly. Okay, so that last one is 14 out of 30. Now, we can go and quickly do the decimal conversions. Okay, so 12 divided by 30. Okay, let's bring the calculator up. Let's just clear it. Oh, nice one without lots of decimals. And then statement A says 2/5. Now, many of you will probably know that 2/5 is the equivalent of 0.4 from your mental arithmetic section, but if it's not your strong point, okay, it doesn't matter. Okay, just go and double check it on the calculator. 2 divided by 5 is 0.4. So this is a true statement. Okay, let's do a quick erase here. Move on to statement B. 4 divided by 30. Okay. Okay, another one of those recurring decimals. Lots of 3's after it. Okay. Now, the statement B says 1 in 10 gained a level 5. I think it's fairly obvious that this isn't going to be the same. Okay. Again, from your mental arithmetic, you should know that 1/10 or 1 in 10 is 0.1. But again, you know, if you want a little bit of comfort, then go and use your calculator. Do 1 divided by 10. Okay. In the previous question, we looked at 1 in 12. It's a fraction, 1 over 12. So 1 in 10, you can write it as a fraction. Okay. So this one's a false statement. Okay, and then just move on to the last one. Hopefully you can see, as you get used to these and you're confident in your method, you can do this pretty quickly. Okay, and of course you guys don't really need to write all of this down. You probably just really need to write the decimals down. So when you do 14 divided by 30, okay, the important thing is to write the answer down. Now, as I say, just maybe write 3 to 4 decimal places down. Okay, and we're comparing that this time with 1/3. Okay, many of you again may know that 1/3 is 0.333, but just use your calculator to double check. And you can see that these two decimals are different. Don't need to think about it, you just move on and say that one's false and move on to the next question. Okay, that's pretty much it for pie charts. From the point of view of having numbers on there and dealing with percentages and decimals, but there is one more type of question which I'm going to cover. Okay, so the last part of the pie charts video, we're going to deal with a very specific question that has come up in the real test. Okay, and it's confused a lot of students when they've first seen it, partly because it's not covered in any of the practice material anywhere, and then partly because basically there were no numbers on the pie chart. Now that might sound a bit weird at the moment, but I'm going to hopefully clear that up in the next few minutes. Okay, so to set you up for the kind of question that you're going to possibly get in the real test, I'm just going to really look at this particular image here, and this should be an image that most of you are fairly comfortable with. Okay, it is showing, mainly it's showing what a quarter of a pie looks like, and any of you should really be pretty comfortable with that. If you cut a pizza or a cake into 4 equal slices, we tend to cut through the middle of the cake and then through the middle again, vertically and horizontally, and you get this kind of picture. Okay, so we've got this little section in the top right of the picture that is representing a quarter, okay, which means the rest of the pie must be 3/4. Hopefully that's pretty common sense to you. Okay, now one way of recognizing a quarter of a pie is to try and look for that 90-degree angle that I've pointed out on the screen. Okay, so a 90-degree angle is sometimes called a right angle. Okay, and it's, you know, right angles are ever present in everyday life everywhere. If you look at any table, okay, tables, they tend to have right angles in the corners. Okay, if you look at your TV screen, there'll be right angles in the corners. Okay, if you look at any building, if you look at a room, you know, the sort of the walls and the floor are set at right angles. So right angles are very important. Okay, now the thing is you would also need to be able to sort of recognize that quarter of a pie, even if maybe this picture was rotated round a little bit. It's not always going to look exactly like that, where you've got a horizontal line and a vertical line that meet. Okay, so try and sort of imagine if this was rotated round, that you would hopefully still be able to recognize a quarter of a pie. So this is very similar to the question that has come up in the real test, in the real QTS Numeracy Skills Test. I'm not 100% sure how many categories were on the pie chart, and in a way it doesn't really matter. You'll see that the technique that you need, it's kind of irrelevant. Okay, so what we've got here is we've got a pie chart. We can clearly see there's 4 different categories, A, B, C and D. In the real test there'll be some names of categories on there. Again, that's fairly irrelevant. Okay, what you're really looking for here is to recognize a quarter of a pie again. Okay, now let's just talk about what the actual question's asking for first. Okay, and I've written that at the bottom there. The question in the test is really asking you to say which sections or which categories add up to 3/4 of the pie. Now, the best way to do that, okay, 3/4 of a pie is more difficult to recognize than a quarter of a pie. Okay, so really what we're doing in this question is we're trying to pick the slice of pie that is closest to a quarter. It doesn't have to be exact, it would be an approximation, okay? And if you look at this red slice of pie here, now this is by no means perfect, okay, but this is approximately 90 degrees. It probably looks slightly under 90 degrees to my eye, okay, but it's close enough, okay? So if we recognize that this red portion here is a quarter, it must mean that the rest of the pie adds up to 3/4. And that gives you your answer in this question. Okay, it would be categories B, C and D add up to 3/4. But notice that's not what I tried to find on the pie chart. I didn't try and imagine that this angle round here, which would be 270 degrees, we don't need to be fancy like that. We need to spot a quarter, okay? And then the rest of them must add up. Now I believe in the real test it's one of those drag and drop questions, and you have to drag those 3 categories into the correct answer, okay? Also notice that compared with the previous image, okay, this 90 degree or quarter of a pie has kind of been rotated round from that standard kind of picture that we see. You need to be able to spot it in a few different circumstances. But that's it. That's all the question is. It's not a particularly difficult question, but I totally understand that anybody seeing that for the first time in the heat of a real test when you're under time pressure, okay, it can be a bit confusing, and people tend to look at it and think, have I seen this in the practice tests? And if the answer to that is no, they tend to panic. Okay, try not to panic in this. Spot a quarter of a pie and you'll be able to recognize the rest of it is 3/4.